So, I'm Ralph Reel with ARC Advisor Group. I'm the session moderator. For the agenda, I'm going to give a little bit of an intro about emerging technologies for field service. So most of it will be IoT, but I'm going to get a little emerging technology. I'm going to talk about augmented reality just a little bit, places where it may fit with field service. Then we'll have the two speakers speak, each for about 20 minutes. And then we go to a Q&A panel discussion, and the technology suppliers, representatives from the technology providers will join the Q&A panel in case there's some questions more specific around the technologies that they use in their solution. All right? And the buttons work. Hey, we're in good shape. We'll talk a little bit about IoT in relation to field service, and then the augmented reality. I'd like to open this just pointing out how ugly unplanned downtime is. And, field service, maintenance is related to preventing unplanned downtime. In each one of these cases, what happens is a piece of equipment goes down, you can't make product, and you lose revenue. And these all represent the typical revenue losses that occur in industries when critical pieces of equipment go down and can't produce product. And beyond just the revenue loss, you also get an issue, particularly in the process industries, where the work in process needs to be scrapped. You have chemicals in the pipelines or in the process, and when it goes down, they are not being processed properly, and they need to be scrapped. So you have losses of work in process inventory, and also you get in trouble with safety. Unplanned downtime, the ugly things can happen. You wind up with environmental or safety incidences. So, why do we have field service? Why do we have maintenance in general? It's to keep the equipment running so production can make product and the company can earn revenue. And we often forget in justifying these systems, making that connection from plant floor issues to the issues that are in the P&L statement and the balance sheet, those issues that get executive attention. There's often a tendency to focus on plant floor issues and really not get the interest of executives. So I want to implore you, when you justify these systems, to try to make that connection to the executives, because when you get their support, you get the resources you need to be successful, and it includes political cover. If somebody's uncooperative, usually can get help to solve that problem. All right, now, what was the world like prior to IoT? And this is actual document from Caterpillar going back 2013. That's when it was dated anyway. And this was the start, the kind of introduction to an end user, what you needed to do to maintain your Caterpillar tractor. And each one of those 7 things is a bit of an eye chart. I'll just point out each one of those 7 things. It isn't like, replace your oil, the maintenance chart that you may be familiar with for your car. Each one of those things is a program in and of itself. So from an end user perspective, maintaining your own equipment is very, very expensive. If we go over to IoT, what Caterpillar now offers is smart equipment, so the equipment has ability to communicate to the cloud, collects data. It's already intelligent. It has at a minimum, has a engine control module on the engine, just like your cars do. And the issue then becomes adding communications. Communicates to a cloud, condition monitoring gets done there to assess the health of the equipment, typically. And I want to just point out, a lot of people say, boy, end users, they don't want to open up the firewall. They don't want anybody touching their equipment. But this was back in 2016, Forbes magazine. There was a survey done. The results on the survey says 61% in the US would be willing to have the OEM monitor the condition of their, collect data, monitor the condition of the equipment for predictive maintenance services. And in Europe, I think the number was 42%. All right, so this is, fairly significant portion of the population is open to this kind of IIoT solution. For this slide, I'm hypothesizing that an end user would outsource their OEM, their maintenance to an OEM, and this would be prior to IoT. What would be the business process if somebody decided to do that? Early in my career, I was in charge of a maintenance department and would have issues with equipment from an OEM, so this part of this comes from that kind of experience. So the first thing is the equipment goes down, you're in a bit of panic, you make a panic call to a call center. The call center then generates a work order, sends somebody out to look at it. The odds are the problem is more involved than they first anticipated, so they have to initiate another work order, and then the right skills and the right parts show up. And you could have a couple of week issue there for the two pass repair, one to inspect and the second one to actually make the repair. And obviously, my career would have been very short if I allowed equipment to be down for 2 weeks and my company lost 2 weeks worth of revenue. So this is the primary reason end users have an on-site maintenance staff, because they cannot have 2 weeks of unplanned downtime for most pieces of equipment, particularly the critical pieces of equipment, all right? And what the inventory refers to is that on the part of the OEM, because you're dealing with a lot of urgency, you got a lot of depots, and you have to have inventory in a lot of depots for that emergency response, all right? So let's go over to what happens in the current world. Well, I'm idealizing a little bit of fully implemented IoT predictive maintenance approach. The alert is, the intelligent equipment generates the alert. Via the web, you receive it. The OEM can look at the parameters of the equipment and assess the health of the asset via the web, pretty much determine what's going on and what the problem is. They send the technician with the right skills and the right parts the first time. And we found in the case stories that we've written, 30 to 80% of the problems can be solved via the internet by adjusting parameters or having somebody local do some minor thing, like push the reset button or something like that. The 80% involves packaging equipment because you have mini stops. So that's kind of unique to packaging equipment. Most people report somewhere around 30%. All right, and then the inventory is lower because you have time to schedule the repair. In the timeline, the problem is identified via the web. You're doing predictive maintenance. You identified a problem is going to occur some point in the future. Depending on how good you are, it could be a week in the future or months in the future. You schedule the repair during planned downtime, so there is no lost production. And then the problem is prevented. So this business process, no unplanned downtime, starts to make it practical for the end user to outsource maintenance to the OEM. All right. In the lower right-hand curve, the first-time fix rate went from, we had an elevator manufacturer measure this. Their first-time fix rate went from 65% to over 90%. They wouldn't tell us the real number. They just said over 90 because this was the early point of collecting the data. They didn't have a full amount of data to really come up with a sharp number. All right. So, and this is one of the reasons why, as the workforce ages and we have a workforce changeover, obviously you have fewer. So what are some other drivers for outsourcing maintenance? What's occurring at the same time is you got generational turnover, and the people who could tell by listening to a piece of equipment that it just didn't sound right, they're not going to be there. And so that's one issue. And the other issue is equipment is getting increasingly complex, both from a design, mechanical, electrical, et cetera, but also from a viewpoint of computers and the science that's in it, how the equipment works. It's getting to the point where it's really impractical to have a general purpose technician working within the plant to maintain the equipment. You know, you train them, but by the time they use that training, there's a lot of decay there, all right? So in this next slide, I want to talk through the business process. You know, we've established that there are some market drivers to outsource maintenance to the OEM. So what's the business process of actually repairing the piece of equipment? Well, with IoT, we bring in data about the equipment. You know, take the example of a pump. You know, you have process data, which would be the temperature and pressure of the fluid around the pump. We can also, with IoT, we bring in the current draw, perhaps, and the vibration monitoring of that pump. So we have a much richer set of data to do predictive maintenance. And our recommendation is to have an automated alert go to the planner, the field service planner in this case. We don't recommend that you have, too many people use verbal communication. And that tends to be problematic because people forget things. So we suggest an automated alert, go to the field service planner. They can do some triage, rank order the problems, and then the ones that go above the line become work orders, and you go out and repair the equipment. Now, in this scenario, this gets complicated from a business viewpoint because there are certain resources that are managed by the OEM, you know, the cloud application, the analytics, sending the alert to the field service manager, planner. Sometimes that planner works for the OEM. Sometimes that planner works for the dealer, a local dealer. And certainly the person who goes out and actually maintains the equipment is the local dealer. So I'm just pointing out that there's business agreements that have to be worked out. The dealer needs to be remunerated for the technician going out to repair the equipment, and there are a variety of ways that can be done. Maybe it's % of the sale, maybe they're paid each time. I think a model is how OEMs, the automotive OEMs, pay their local dealers for recalls. You know, in that case, the local dealer is paid a discounted price, basically, for the implementation of the recall and whatever change has to be made in the car. But that's, you know, on a case-by-case basis, that needs to be worked out. All right? And it's complicated. It's not easy. All right? Now I'm going to switch gears. This is what I've talked about before. We have a lot of clients who are doing field service, OEMs, and so we have a lot of knowledge about their state of the business and the issues they're driving. This part of the presentation is really ARC hypothesizing where augmented reality could be applied in the field service. We don't know of people who are actually doing this yet, is my point. So, you know, if a few years from now turns out that this didn't work out, please kindly forget this part of the presentation. All right. So I'm going to, you know, there's a bunch of AR applications that people talk about. I'm going to focus in on maintenance diagnostics and remote repair. So, you know, one of these augmented reality applications where you have a tablet or a smartphone, you point it to a piece of equipment, and then the piece of equipment knows, the application figures out what it's pointed at and starts populating the screen with data. Even with today's applications, that is not easy to develop. It could cost $200,000 or so to develop. So right now, we don't see this occurring in end users. But an OEM has hundreds, maybe thousands of pieces of equipment that application can be used on. So you get some economies of scale, and on a per piece of equipment basis, it starts to make a lot of sense. And here I'm pointing out that the display contains process data like the steam, all right, the temperature of the steam, but it also contains equipment data. And this provides the kind of information that a technician would need to do problem isolation and debugging and can figure out where the source of the problem is. Because these systems are complex. And they have many components, maybe many subsystems. And nowadays, problem isolation is definitely non-trivial. I'm sure some of you experienced this kind of problem when you took your car into a repair shop. Getting a technician who can really figure out where the source of the problem is non-trivial. And we have that. So we foresee augmented reality eventually being adopted by OEMs for improving that mean time to repair a metric and the first time fix rate for field service calls. Now I'm going to get really wild and crazy. We're thinking that bringing in a remote expert. So you're an OEM with very complicated pieces of equipment, and you have a technician who's on site, but he gets into an area that he needs help with. And we've found people have tried to use Skype and the smartphone for the video chat with the remote expert, and that has been problematic because the video quality and where they are and stuff like that. So and lighting, et cetera. So we're starting to hear people talk about using 3D glasses. Now these are ones where the lens is translucent. So, and this inset here is when it's from Microsoft when they first announced HoloLens. What the application that comes with these glasses is two things. One is these glasses see 3D space. So in the case of Microsoft, they took the Kinect technology that came with the Xbox game. They made it real small. It's in the headset. So that headset sees 3D space. And Dacry has done the same thing with similar thing with their smart glasses. So that when, in this case, the father here, this is a Microsoft example, the father is giving his daughter help remotely to fix a plumbing problem. When the father here makes a notation, that notation goes on either the equipment or on the part that she's holding. And when she moves her head or backs off, because the 3D lens is 3D space aware, that annotation stays. So you move your head, the annotation stays on product, all right? So it becomes a much more meaningful way to give direction to the less experienced technician by a more experienced one, in this case, the father to the daughter. So we're seeing this potential in the toolkit for field service people as they go to a site, a way to bring in an expert. There's also another potential that if you're an OEM and you're offering your client a high-value SLA maintenance support contract, you could give this to your end user, and when the general purpose technician runs into a problem they can't solve, you could also use this as a means to have the help desk direct their efforts more better. So these are some wild ideas where that may play in the future. We'll see how it works out. So this is kind of a maturity chart where we start off on the low end, the reactive support, break, fix, respond. Then the next level is you're doing remote conditioning monitoring and you're sending your end user alerts when things aren't going well. And then finally, you really take over and you have your local dealer visit them to make the repair before the failure. Now, in this session, just to be clear, at least I think we are, based on, I haven't had a chance to preview the presentations. I think we're talking about the maintenance services that involve field service management where the dealer or someone visits the customer and makes the repair before there's a failure. I think we are, aren't we? Yeah, I can see the heads going up and down. All right, all right. Whew. Okay.